So 4.7 day 2, we're looking at inverse trigonometric functions. We're going to evaluate compositions with inverse trig functions. So we need to know some of the properties. So remembering inverse, when we're trying to find the inverse, note that we have f inverse of x, that just equals the x. Then we have f inverse of f of x, that just equals x. So for looking at the trig properties, we have if x is between -1 and 1, and y is between -pi/2 and pi/2, then sine of arcsine of x equals x, and arcsine of sine of y equals y. So I want you to just note that here for x, that has to do with our arcsine, so our inverse sine, and then the y values have to do with the sine of y. Okay, so just notice the restrictions on that. For cosine, we remember that the x value has to be between, for arc cosine, has to be between -1 and 1. And then for the arc cosine, the y value has to be between now 0 and pi for cosine. For tangent and arctangent, so x can be any real number, right? Just thinking about the graph, it goes on forever for the domain. So there's no restriction for our x values, but we do have to remember our y values. We can only go from the -pi/2 and pi/2. And again, that applies to here, the tan of y. So look at those restrictions, so that way it has to be within it in order to evaluate it. We need to keep in mind that these inverse properties do not apply for arbitrary values of x and y. So if we look at arcsine of sine of 3 pi/2, that actually does not equal 3 pi/2. So the reason why is if we're looking at arcsine of -1, we plugged in sine of 3 pi/2 is -1, we would have to use -pi/2 for this arcsine because we're restricted to that interval. And so that's not 3 pi/2. So one thing that we can do is we can find the coterminal angle for 3 pi/2, so we subtract 2 pi. So this is going to be 3 pi/2 minus 4 pi/2, and so this is -pi/2, which would make it equal. So we could rewrite it arcsine of sine of -pi/2, that will equal -pi/2. And so we'll see that in just a moment. So possible to find the exact value of each expression. We have tangent, arctangent of -5. So we're looking at arctangent first inside. And so -5, x has to be, can be any real number. So there's no restriction. So the x value with the arctan. So with this one, it is just, the answer is -5. We have arcsine of sine of 5 pi/3. Now the sine, the y value, so looking up here, that y value has to be between -pi/2 and pi/2. And we could find the coterminal angle. So 5 pi/3, let's see if it works. Subtract 2 pi. So this is 5 pi/3 minus 6 pi/3. So that answer is -pi/3. So we could say that this is the arcsine of -pi/3. And so that answer would be -pi/3. Last example, we have cosine and arc cosine of pi. So the arc cosine, we're looking here, arc cosine, we have to look at the x. Now notice we're looking at the x has to be between -1 and 1. And we're looking at pi. Pi is approximately 3.14. So therefore this is not in the domain. Not in the domain, so it's not possible, or it might say in the book, not defined. So try these 3 examples. Try these out. For tangent, arctangent of -14, that's -14, so that one works out perfectly. Letter B, you have to find the coterminal angle, and we see that it's -pi/4. Then we have cosine, arc cosine of 0.54, and remembering this value here is between -1 and 1, so this works, so it's just 0.54. So let's evaluate, we're evaluating compositions of functions. Find the exact value of each expression. We have tangent arc cosine of 2/3. So notice it's different here. So arc cosine. We can let u equal arc cosine of 2/3. So we can rewrite it as cosine of u equals 2 over 3. Now, why I want you to think about that is because we need to draw a triangle, and remembering that what does 2 and 3 represent? 2 is our adjacent, and 3 is our hypotenuse. So adjacent, this is 2, this is 3. And we want to figure out what tangent of that is. So we're missing something. We need to figure out what this side is here. So we can do that as 3 squared equals 2 squared. I'm just going to call it y squared for now. And then solve. So this is 9 minus 4 equals y. And let's take the square root. So 9 minus 4, that's square root of 5. That's this value here, square root of 5. So now we can think about tangent. We're trying to figure that out. Tangent is opposite over adjacent. So therefore, this answer will be root 5 over 2. Okay, so that's how you evaluate these. So you have to draw a triangle with what you have. We have arcsine of negative 3 over 5. Remembering arcsine has to be within a certain interval, so that has to be here. So we know that we're looking at this value down here. So let's draw a triangle. So here's theta. Here's theta. Sine, that is negative 3 over 5. That is opposite over hypotenuse. So this is theta. Opposite from there would be, this is negative 3. And 5 is the hypotenuse. So cosine, we know we're going to have to find this x value here. Oh, and this is a right triangle. So let's solve for that. We have 5 squared equals negative 3 squared plus, I'm going to call this x squared. So this is 25 minus 9 equals x, and then we're going to square root that. 25 minus 9 is 16, square root of 16. So therefore that x value equals 4. So remembering cosine equals adjacent over hypotenuse. So this value is 4 over 5. Try this next example. Find the exact value of cosine of arctan of negative 3/4. So trying this out, you see that you have arctangent. Tangent is opposite over adjacent. So opposite's negative 3, adjacent is 4. Then you find the radius, and that is 5. So cosine is adjacent over the hypotenuse, so therefore it is 4 over 5.